Okay, we're back. This is the second video. We just completed 43, so let's move on to problem 44. Already set up quite nicely. Quadratic and linear term on one side, constant on the other. This is what we want. Let's divide every single term by 2 because we want for a to be 1. 2x squared divided by 2 is x squared. We'll get negative 12x. Leave some space, equals negative 1. The factor that we want to build will be half of negative 12, so we'll have x minus 6 squared. The number that we want to put here is negative 6 times negative 6, so we'll add 36 to both sides. Negative 1 plus 36 is 35. Now we'll take the square root of both sides and find that x minus 6 equals plus or minus the square root of 35. Our last step to get x alone is to add 6 to both sides. So our final answer is x equals 6 plus or minus the square root of 35. Okay, let's try 45. Hopefully this one will do what I'm hoping. All right, quadratic term, constant, but the linear is not on the same side as the quadratic, so that's the one I want to move. So I'm going to subtract 24x from both sides. 4x squared minus 24x is just 4x squared minus 24x. They can't combine. They're not like terms. Combine to a single term anyway. All right, what I can do now is divide every single term by 4 because we want a to be 1. So I'll have x squared minus 6x equals negative 25. To solve this, we will have a factor of x minus 3. That's because minus 3 is half of minus 6 or negative 6. And if I take negative 3 times negative 3, I will get 9. So I'm going to add 9 to both sides. This is close to what I want. We have negative 25 plus 9. That gives us negative 16. When we take the square root of both sides, we will have x minus 3 equals plus or minus. Because of the negative, we're going to have an I, and square root of 16 is 4, so plus or minus 4i. Then we'll add 3 to both sides. We're left with x equals 3 plus or minus 4i. I want to pretend that we had a slightly different problem. So this was the correct answer here. Yes, we're done with it and happy with it. But suppose that, I want to subtract. Suppose that we'd gotten to a place where we had a problem. Again, this is made up. This is not one of these problems. Suppose we had one that said x minus 3 squared equals positive 16. In this case, when we square root both sides, we get x minus 3 equals plus or minus 4. At this point, there are no radicals. So I would write the equation in two ways because we're going to get two distinct answers, and we can simplify these answers to be single digits. So I'm going to solve for x minus 3 equals positive 4 and for x minus 3 equals negative 4. And for both equations, to get x alone, I'll add 3 to both sides. In one case, I got x equals 7, and the other was x equals negative 1. Sometimes my students will add 3 to both sides here and incorrectly assume that the answer is plus or minus 7. You can see where they're getting that from. But you can also see that if we write it out in both ways, we're going to get two very different answers. They don't end up being the same thing. I wish one of these problems had had an example like that, so I'm sorry that they didn't, but anyway, we've got that part taken care of. Okay, let's move on to another section. Let's see, let's do this last bit here. So when we divide, we've got 5i over 2 minus I. Remember that I equals, by definition, the square root of negative 1. So we essentially have a radical on the denominator, and to be simplified, mathematically speaking, we don't want a radical on the denominator. So to get rid of that, I need to multiply by something very creative here. Now, if I had a monomial, I could just multiply by I, but if I did that in this case, notice that my denominator would be 2i minus I squared. And while minus I squared can become positive 1, I'm still left with an I on the denominator, 2i plus 1. So I've got to be a little bit more creative as I do this, and we've discovered that if we multiply by the complex conjugate, meaning the same numbers, just the different sign, you'll see that the sort of linear terms here will cancel away, and when we deal with I squared, that becomes -1, so we'll be in good shape. Let's try this. Oh, also, of course, if we multiply the denominator by something, we need to multiply the numerator by that same thing in order for the equation to continue to be congruent. This is a cool version of the number 1 that we're multiplying by, and if you multiply a number by 1, it still equals the same thing. Okay, I'm going to distribute here. 5i times 2 is 10i, and 5i times I is 5i squared. Let's take a look at the denominator. 2 times 2 is 4. 2 times I is 2i. Negative I times 2 is negative 2i, and negative I times I is negative I squared. At this point, I want to take a look at the terms that have I squared with them. So there's one, and there's one. These we can simplify because I squared equals -1. We discovered that once before when we said that I equals the square root of -1. So I squared equals the square root of -1 times the square root of -1. And we used patterns. We said, okay, square root of 3 times square root of 3, well, that equals square root of 9, which is just 3. And if I do that same thing with like square root of 7 times square root of 7, guess what I'm going to get? 7. So in this case, when we do square root of -1 times square root of -1, our answer is going to be -1. Okay, that was just a recap on the lesson that we had learned to discover it, but now let's put it to use. So since I squared is -1, we're going to take 5 times -1, and down here we'll take essentially 1. We didn't put the coefficient there, but we could. -1 times -1. So this is going to become +1, isn't it? So negative I squared is -1 times -1. It becomes +1. 5i squared is 5 times -1. It's going to become -5. Oops, didn't want to subtract that. -5. So my simplified numerator is -5 plus 10i. That's the conventional way for writing a complex number. We do the real part and then the imaginary part behind it. Okay, our denominator, is going to be 4 plus 1, so that's 5. And notice what happened here. Positive 2i, negative 2i, they become 0i, or 0 times I is still just 0, so they go away. And we did that on purpose. That's why we chose the complex conjugate, so that we could get rid of that middle term. All right, one last thing to consider here is the fact that both -5 and 10i are divisible by 5, so we can go ahead and simplify that. We can take -5 divided by 5, and then positive 10i divided by 5. So we should end up with -1 plus 2i. Is that the answer you got? All right, let's try 38. I have a binomial here, so I'm going to use the complex conjugate again to get rid of the radical on the denominator, or the I on the denominator. Okay, let's start with the numerator. 10i times 5 is 50i. 10i times -i is -10i squared. And we'll come back and simplify that later. Let's do the denominator now. So sometimes we've had students that are still struggling with this notion. So when we come across a binomial times binomial, what we're going to do is take the first number in the first binomial and multiply it by each of the other terms in the binomial. So 5 times 5, that's going to be 25. 5 times -i, that's going to be -5i. Now notice that I've multiplied this 5 by every term over in that other binomial. So now I'm going to move on to the other term in my initial binomial, this positive I, and I'll multiply it by each of the terms in the second binomial. So I'm going to take I times 5, that will give me positive 5i, and I times negative I, that will give me negative I squared. All right, now let's simplify what we've got. Oh, I meant to highlight there. Negative 10I squared is positive 10, right? Because I squared is negative 1. So if I multiply those together, I'll get positive 10. Negative I squared, that's negative times negative 1. So positive 1. Negative times negative is positive. So we've got that and this. So my new numerator is 10 plus 50I. My denominator is 25 plus 1, so 26. And once again, just like we were hoping, these cancel out. So that's all we have on our denominator. Notice that every term is positive, or each term in the numerator and the denominator, sorry, they are all positive, but I meant even. They're all even. So I'm going to divide each number by 2. I'll be left with 5 plus 25I all over 13. So that's the simplified form of what we want there.